For centuries, we've looked at the stars and assumed the universe was mostly silent, a vast vacuum punctuated by predictable explosions and the steady glow of distant galaxies. But what if the universe isn't silent? What if it emits a kind of sound we didn't know how to hear? Imagine this, a ghostly whisper emanating from the heart of our own galaxy, the Milky Way. A signal captured by our most sensitive instruments, strong enough to be undeniable, yet too strange to be classified as normal stellar activity. It doesn't pulse like a pulsar, it doesn't blink like a magnetar. It just lingers there, eerily constant, exactly where our maps tell us dark matter should be densest. This raises the question that is keeping astrophysicists up at night. What if dark matter is already sending us signals, and we've only just now learned how to identify them? Are we finally detecting dark matter trying to introduce itself? The first clue in this cosmic puzzle came from an unexpected place. The trail begins with the European Space Agency's Integral satellite. Its mission was to map the most violent and energetic sources in the universe, but when it focused on the galactic core, it found something different. Not an explosion, but a persistent glow. A razor-sharp peak of gamma rays at exactly 511 keV. To physicists, 511 keV is more than just a number. It's a fingerprint. It's the exact energy released when an electron meets its antimatter counterpart, a positron, and they both annihilate in a pure flash of light. Something at the center of our galaxy is producing an ocean of positrons. The truly intriguing detail? The light is strangely uniform. If exploding stars, supernovae, were the culprits, we'd see clusters and hotspots like fires in a forest. Instead, the glow stretches for thousands of light years across the central molecular zone like a sheet of silk. A smooth, diffuse haze. All research since the first detection in 2003 says the same thing. Too broad, too smooth, and crucially, its shape seems to perfectly match the dark matter halo we had already sketched out from how its gravity bends starlight. So the hunt began. We did a roll call of the usual suspects. Black hole jets? No, they are like cosmic fire hoses, shooting energy in narrow beams, not a widespread mist. Pulsars? They spin with clockwork precision, and their energy spectrum doesn't match. Supernovae? They explode and fade. This glow has been constant for decades. Not even the new census of magnetars from the CHIME Observatory, the most powerful magnets in the universe, can mimic this diffuse glow. Each of the likely hypotheses fails the test. Wrong spectrum, wrong timing, or simply not enough energy to drench the sky in 511 keV. So if the usual suspects are innocent, we need to seek our answers from other cosmic players. A recent publication on Archive, the forum where physicists debate their boldest ideas, proposes a new culprit. An ultralight dark matter particle with less than 10% of a proton's mass that silently decays into positrons. It's not a violent explosion, but a slow, steady process happening throughout the galactic halo. These orphaned positrons then find electrons in the surrounding gas, ionizing it and generating the uniform radiation we observe. It's an elegant theory that perfectly explains the shape and energy of the 511 keV glow. But a single clue doesn't solve a case of this magnitude. And this isn't the only strange signal we've found. In a moment, we'll talk about the enigmatic 3.5 keV line, a second whisper coming from even farther away. But before we dive into this second enigmatic signal, if you want to learn about other mysterious signals from deep space, click the card above and watch the recommended video. All right, back to the mystery. While the 511 keV glow is our closest signal, another, even more subtle one was detected by the XMM Newton and Chandra telescopes. While observing massive galaxy clusters like Perseus and Andromeda, places teeming with dark matter, they found a faint but persistent emission line at 3.5 keV, a frequency where nothing should be. Theoretically, this line doesn't correspond to any known atom or atomic process. It appears where there's a lot of dark matter and is absent where there isn't. An isolated line could be a fluke or an instrumental error. But two independent lines, at different energies, both tracking the predicted density of dark matter, start to look like the writing on the wall. In labs here on Earth, scientists are not waiting for dark matter to send us a signal. They're trying to provoke it. They're firing high-intensity photons of exactly 3.5 keV into a vacuum cavity, hunting for the nearly impossible nudge of a dark photon, a messenger particle of a dark force. So far, there has been no results. But in science, silence is also informative. Every non-observation cuts away another piece of the vast parameter space, narrowing the target for the next round of experiments. The hunt is closing in. Dark matter fans used to dream of a single, thunderous discovery, but reality might be far more subtle and, frankly, more beautiful. Perhaps we aren't looking for a single bang, but a constant chorus of whispers across all the frequencies we can measure. By analogy, if the 511 keV glow is the bass and the 3.5 keV line is the treble, then the limits the James Webb Telescope is placing on the tremor of gravitational mini-halos in the infrared could provide the missing harmony. Putting it all together, we might just have the first picture of dark matter. Let's recap. A uniform gamma-ray glow in the galactic center? Check. A persistent X-ray line in distant clusters? Check that too. Laboratory corridors narrowing down to find the exact particle? Check that too. Each piece of the puzzle, on its own, could be an anomaly. Together, they might be telling a story. The core of our galaxy is shining with a light that ordinary stars can't produce. Either astrophysics still has a lot of homework to do, or an entirely new particle, which makes up 85% of the universe's matter, is finally stepping out of the shadows. Whatever the winning answer is, the next clue is already on its way, racing through space and time to reach us. We are on the frontier of a new astronomy, one where we not only map what we see, but also decipher the messages in the dark. The discussion doesn't end here. What do you think? Are we on the verge of finding dark matter, or are these just cosmic coincidences? Leave your theory in the comments. Subscribe to get the alert when the next batch of data arrives. Until next time, keep questioning the universe.